in my afternoon. Yeah, so how can you approach such kind of a subject? While I was preparing for this talk, I was thinking a lot about it, and I could easily talk hours about the theory, and like no one would just sit and listen to boring stuff. And on the other hand, I could also just dive straight into coding, but I knew that that wouldn't make it either. You see, the problem with this kind of stuff is that much of the real creative work is done in solitude. It's like sitting alone and trying things for hours. It's like breaking stuff, failing, starting from scratch, rewriting and redoing stuff over and over again until stuff suddenly starts clicking. So in a way, I figured I could inspire people a little bit. I could probably inspire people a little bit by telling a story instead, one that approaches the subject through the prism of my own experience. And funnily enough, it's a story that doesn't start from the beginning. It's a story that starts from the end. At the end of the story, there was a book, like kind of a different book. It had none of the usual suspects in it. For example, there would be no talk about web servers, no networks, no containers. I think the book wasn't even supposed to teach the language as much as it was meant to inspire people to try new things, to think beyond what's possible, to think beyond the usual, the daily use cases they're used to. Interestingly enough, it was also the first sort of a product that I released after taking the hard decision to jump into the unknown waters of entrepreneurship at the beginning of this year. And yet, this book is only a product. It's only a byproduct of a much longer journey. It's actually the journey that will be the focus of the rest of my story than the book itself. It's a story about finding new sources of inspiration. It's also a story about picking up gold later in my career. It's like unlike others, like I actually picked the language fairly recently. But last but not least, it's a story about rediscovering the joy of programming through the language. So, what's my journey? The story, my story with graphics, I would say begins in the early 2000s. It's like around 2002, 3, 4. And, like many kids at the time, I also wanted to make video games. I was obsessed with, especially stuff from the late 90s and the early 2000s. Like graphics was a budding field back then, so everybody wanted to do that. I started with programming C and Pascal, but then I quickly realized that, while that was fun, the languages the languages combined with the frameworks weren't allowing me to make the quote unquote flashy stuff as fast as I wanted. So somewhere around that time, I spotted a new language on the scene. It was called processing. And as soon as it appeared, I immediately bonded with it. I immediately started playing with it. Interestingly enough, processing was born, it originated at MIT. It was born out of the need to teach programming to non-experts, especially people from the, I would say, not so sciencey background, like people with, artistic inclinations. And it was quite of a different experience when it popped around. From the get-go, it was based on Java. The language looked and felt a lot like Java, because it actually is, but it also took a lot of shortcuts and simplifications to make things much easier to understand and start with. It also came with a jam-packed library for working with graphics. You wouldn't need to import a lot of stuff or bring in a lot of third parties. Everything was I know it's kind of a dirty word, but like much of the stuff was in the global scope, so it was super easy to just kind of get the functions that you wanted and start doing magics with it. Um, and yeah, like many processing works, or like as people call them, sketches, they would look something like this. This was actually one of the original sketches that I started with, and interestingly enough, it was later on, like many years later on, it was the one that inspired me to write the book. And yeah, it's looking at it, there's actually nothing really complex about that stuff, which is one of the points that I wanted to emphasize in this talk, that um, this kind of creative expression doesn't have to do with complexity in the sense of writing complex code. It's actually much simpler. It's actually the multiple iterations over and over and over and over again that lead to the complex behavior growing out of it. Yeah, essentially, as I said, nothing too fancy, nothing too complex. It's really just picking a couple of colors from a source image, and drawing random rectangles with varying degrees of opacity that would give it the depth of field effect. So I took this obsession with processing a little bit further down the line into my master's degree. That was the beginning, and in the beginning of 2010, so it was late 2010, when destiny led me to the University of Bremen, and met me with one of the forefathers of the graphics field. Maybe some people know him, a German guy called Rachev, of whom I was a student at the time. And it was through our conversations that I actually started reading more and more about the philosophy of the thing, and not just putting those squiggly lines on the screen. I actually started theorizing what the philosophy was behind it. But yeah, life, it always takes over in a typical fashion. So after I graduated from the university, I quickly moved on to the IT industry. I became a Java developer, and for the next years, up until fairly recently, I was still a Java developer. Made a career, like switched a couple of jobs, was here, was there, like picked up a bunch of experience. And it was about the end of 2018 when I was in a way of switching jobs. I was introduced to the Go language. It was a very interesting encounter at first, because I had a lot of baggage from my past experience, especially doing this complex enterprise stuff. But when I met the language, it was a little bit of a love at first sight. I was so hooked on the simplistic nature of Go that I started using it for many other things outside of the scope of my projects. I think it was the pivotal moment that was going to define my future trajectory. At some point, I figured, maybe I could use Go for picking up my old processing sketches and seeing what would come out. And yeah, I think some people say that the experiment was successful, as some people would say the rest was history. But how does generative art actually relate to Go? And to begin with, what is actually generative art? That's a bit of a complex topic to go into, and I'm sure that whoever looks for definitions of algorithmic and generative art would get probably 100 different definitions. And the problem is that none of them would actually fit to the context of Go, because they were made by artists and not so much by programmers and engineers. So I had to come up with my own definition, and it would probably you would allow me to share it with you. Generative art is a balance between procedure and randomness. It's the result of simple steps multiplied many times over. A complex organism of tiny actors interacting sequentially and concurrently with one another. If you think about it, a lot of this actually applies to the Go language too, doesn't it? Actually, the animation that you see on the right was done by me and entirely in the Go language, and I think, at least to me, it symbolizes what generative art should be about. It's like a bunch of tiny little agents that kind of spring from nowhere and everywhere at the same time, moving in different directions, having different colors, and still everything kind of mangles together into this beautiful complex organism that springs out of it, multiple iterations over and over. All right. Let's look at some of the basic building blocks that the standard library provides us with. As is usual for the Go language, we are provided with only a bare set of basics here. I should take a step back and just say that whenever I mention graphics in this context, I'm currently only speaking about pixel or raster graphics. Although there are many possibilities and there are libraries that deal with vector graphics as well, this was not my original intention, and that's not so prevalent in the standard library either. So the standard library would help a lot with raster graphics, and that's what I wanted to focus on. So yeah, back to the core concept. We don't see much from the, if you approach graphics programming in the Go context, you would think there's actually not much. There's not like a lot of complex libraries for primitives and stuff like that. But the limited set of packages and sort of base constructs that you're provided with, these three interfaces, if you will, they're so well designed that one needs to know their contracts and immediately be able to start building stuff on top. So, for example, for any type to qualify as an image, it only needs to implement these three methods here, and this is not complex. The same applies to color, right? Like you only need to implement a method that returns a red, green, blue, and an alpha channel, which are essentially just integers. There you have it. You have a color. You could essentially think of each of those interfaces as the reader and writer of the graphics domain. They're so prevalent in the standard library, and they're so prevalent in third-party libraries that it's super easy to start working with them and build on top. It's also this idea of composability and swapping around that made Go so interesting to me as a programmer. Yeah, as I mentioned already, there are a couple of good third-party libraries that step on top of those concepts, and I would like to discuss them a little bit later on as well. Let's look at one example. I think there's no better way to speak about composition of types than the concept of image filters. You see, a filter in Go is essentially an image too. It's an image that wraps a source in itself, and if we successfully implement all the methods of the image contract, the three methods that I showed before, we could just easily take our filter, wrap a source image with it, and use it everywhere else where an image would be required. So in our case, we don't need to look at other details than the at method, which is essentially saying whoever calls you with this X and Y coordinates, just return a color. What it would do is it would source the color from the original image, and it would return, it would compute the luminosity, which I don't expect anybody here to, to know what this luminosity is. As I honestly didn't either. I just picked it up in the literature, but basically this luminosity says, compute the grayscale value out of a color and return that instead. Another simple example, circular mask. I think this example was actually in the Visual Go documentation, if I'm not mistaken. It's a very very similar experience in which rather than returning a solid color, it would return in alpha 0, or it would return a transparent pixel for any sort of pixel which is not on the boundary, which is not on the radius of the circle, and the overall effect is essentially the same. We could wrap an existing image with our circular mask, use it everywhere else where an image is accepted, and it would work with, it would work as expected. It would just show the circle and not the rest. Right, but still, implementing all those things by ourselves will be an overkill, right? Yeah, I have to agree. As a software engineer, I'm used to working with libraries, and of course, there are a lot of good Go libraries in that domain. Thanks to the composability and the lack of abstractions, these ones are extremely easy to integrate with. For example, I wouldn't be able to write the book or implement the examples in the book so easily if it wasn't for GG, as it's known. It's essentially, I would call it the Swiss Army knife for two-dimensional Go graphics. It's so easy to start with. It reminds me of a lot of processing. It has a lot of this kind of look and feel of, let's create a new context, let's draw a circle. It comes with, all of the easy primitives that could get you started right away. Like the circles, rectangles, polygons, lines, you name it. It also comes in with handy functions for loading and saving images. Yeah. So before I jump into a short demo, I just wanted to give a slide to a couple of notable mentions that didn't make it into the stock. One is something that I actually spoke about in my book, but it didn't make it here because it's the whole world in itself. It's WebAssembly. Hopefully, I'll be able to demonstrate it in a way in the short demo that follows. The other one is something that I'm currently working with. It's the concept of genetic algorithms, which is I'm hoping that by the next GopherCon, I would have a lot more experience with, and I would be able to have, let's say, a whole separate talk on that alone. And last but not least, a very notable mention of one of the books that actually made it for me. It's called The Nature of Code by Daniel Schiffman. This book, it discusses processing, but it also gives a lot of examples on how to approach the graphics context with the processing language. And it served as a huge inspiration for my book. Actually, I was, I can't say enough words about Daniel Schiffman's work. Like I can warmly recommend it to everyone who wants to proceed in that domain. So with that said, I would quickly jump into a demo, hoping that the time would be just right. Let me to move away from this. So there will be actually two demos. One of them is on the web. One of them is in code, and the overall result will be something like this. This is those who have had the chance to look at my book. This is the core example I'm discussing there, and essentially it's a very simple sketch. Just It uses a lot of GG. There's nothing too complex about it. As I mentioned, there shouldn't be, this field is not about complexity as it's about being able to achieve a lot with procedural, iterating on top of simple procedures. So essentially, what happens here is we have a main function. Here's our main function that loads a random image from Unsplash. I'm actually a huge fan of this thing here. It would, I don't know if many people know it, but Unsplash actually has an API that provides random images from the entire collection. So many times I wouldn't even want to look at the source image itself. I just want to be totally surprised by the color combinations that come out of it. So I would load this image and start the sketch with a bunch of cryptic parameters that I think only matter to me, and then in a very simple fashion, what happens is over a lot of iterations, I would continuously call the update method of the sketch, which essentially does nothing much more than drawing polygons on the screen with various colors picked up from the source image in various dimensions, various rotations, and with various degrees of opacity. So let's see how this works. It supposedly will go pick an image, and then it starts the long journey of generating the code, the final image, and hopefully we'll have something new. It's not the best color combination to my taste, but let's try it once again. This was much faster than I expected. That one seems a lot more interesting. I have to say, guys, like I honestly have no clue what would come out at the end. That's why one of the things that I mentioned at the beginning, like there's a lot of just trying and seeing what works, and what parameters work for one setting might not work for another, and it's a lot of fun. So that demo aside, I wanted to actually quickly switch to my browser. And don't worry, these URLs, I will make sure to share them. But this is something that I quickly baked in before my presentation. So it's like I was even crossing my fingers whether it would work at all, but actually it did. So what happens here is we load. So I compiled one of my newer sketches into a WebAssembly file, into WASM, and I loaded it into a web app. So everybody going to this URL could essentially just go and generate a sketch on their own. And hopefully, if I do it, and if I cross my fingers really hard, yeah, guys, that's how you see, how much of a demo experience that is. Okay, it loaded something. So it once again loads an image from Unsplash, like a completely random one. I have no clue what it is. I don't even have a clue if it's going to work, but let's cross our fingers. It's actually fairly slow. This whole WebAssembly approach is quite slow, and yeah, it seems like it won't. Maybe it's because I'm also streaming and it's taking way too many resources at the moment. But this is essentially something that I can advise anyone to just go and try on their own. Let's give it one more try. That was the reason why I tried it beforehand. All right, now it started. Right. Just a little bit more. Hopefully it will speed up by the end, as you saw in the previous in the previous demo that I did. It does feel like it speeds up at the end because I usually play with, I call them brushes. I play with brushes with bigger strokes in the beginning, and I've noticed that they take a considerably larger amount of time to render in the beginning. But by the time they should be significantly reduced, and at the end, it should result in a faster experience. Well, it doesn't seem much faster to me, but just bear with me for a little bit more. Here we go. Here we go. Surprise, surprise. I really hope that it will be a good one. Drum roll, please. Yay! And there we have it. Okay, interesting. So, yeah, as we all know, the beauty is in the eye of the beholder. So, like some people might like it, others might not. But I can totally advise anyone to try this. And yeah, as I mentioned before, I'll make sure to put all the interesting URLs in the, as well as the source code in the slides. And there's already a dedicated repository that has been part of my book as well. So I'm constantly updating it with all the sketches that I'm doing. So yeah, without further ado, I want to thank you guys, and yeah, I'll be hanging around in the networking area after the talk.